3.8, we're going to talk about the role of water in helping the alkaline exhibiting the basic properties. Just like the previous sections, we have learned about the role of water in acid. In acid, they need water to help the acid to ionize to give H+. So this time, we need water to do the same thing. So we help the alkaline to dissociate to give hydroxide ion for the alkaline property. So first of all, you can see that alkaline dissolve in water to give hydroxide ion, and these hydroxide ion are responsible for the alkaline properties. If you have OH minus, you have alkaline properties. If you don't have, sorry, you don't have any. But this time, you have to pay attention to the keywords I use. This one, we call it dissociate. It's different from the one that we've used previously. The one that we use is called ionization. The difference is like this. For dissociation, it means that when an ionic compound dissolves in water to give mobile ions. So you can see that we got an ionic compound here, sodium hydroxide. This is ionic because we have a metal ion. So we got an ionic compound, and when we put it into the water, they give ions in it. So most of the cases, we are having ionic compound in alkaline or alkaline or base, because we know that they will have metal oxide and metal hydroxide. All these, because we contain metal ion in it, so we know that, they will be ionic compound. But we do have exceptions, we have ammonia, which is not ionic compound. Ammonia is NH3, consists of non-metal only. So most of the times, when we have base or alkaline, they put it in the water. For alkaline especially, because base is insoluble in water. So when you put alkaline into the water, it dissolves, it dissociate in the process to give it the ions. So difference between dissociation and ionization. Basically, for dissociation, means that ionic compound to form ions. So you see that this one is ionic compound, and then they become ions. So in the process, we say that sodium hydroxide dissociate to give sodium ion and hydroxide ion. But if we have a covalent compound in like the one in acid, we know that in acid, pure acid, they are covalent compound. Is that right? For example, HCl, H2SO4, CH3 COOH. So all these, you can see that they are covalent compound. Covalent compound, we suppose don't have any ions in it. Is that right? So therefore, in the process, we say that it becomes an ion. Becomes an ion from a covalent compound. So the terms we call it ionization. So right here, we will say that HCl ionize in water to give H+ and Cl-. But for this one, the verb that we use is dissociates, to give sodium ion and hydroxide. This is the main difference for dissociation and ionization. So dissociation of sodium hydroxide. This one is a strong alkaline. Later on, you'll learn a bit more about the strength of alkaline. But when we have NaOH, we know that this is a ionic compound. Ions, not mobile in this case, That is a ionic compound. So therefore, in the process, we say that dissociation, and they become mobile ions, So this one, we call this one dissociation. You can see that, if we zoom in into the solution, if we can see the ion in it, so all of them, the NaOH, they will separate into OH minus, Na plus, So you see that every sodium hydroxide, they break into the sodium ion and hydroxide ion. But in ionization of ammonia, this time it's a weak alkaline. You see the terms that I'm using for this one, we are using ionization. Reason, because you can see that NH3 is a gas, alkaline gas. When we put it into the water, basically we can use NH3 aqueous to represent ammonia solution, just like previous videos when we talk about the reaction between the metal ion and ammonia solution. So in this case, when we put it into the water, what happened in it? So you can imagine, we have a NH3, the water It's just like this. Okay, so the NH3 can grab part of the H from the H2O and then leaving the OH minus behind. So that's why you can see that NH3 grab the H, become NH4 plus, and then the OH becomes OH minus. So this is what happened when we put an ammonia gas into the water. It will react with the water molecule, get the H, become NH4 plus, and leaving OH minus behind because this OH minus left behind. Okay, so this bring up to the alkaline properties. Okay, so this gives the alkaline properties of ammonia solution. Okay, so in the process, okay, we have a covalent compound become ions. Alkaline covalent compound become ions. So we say that, okay, they are changing the bonding, change in bonding. Okay, so therefore we'll use the word ionization. And you can see that this time the molecule, okay, these are the molecule. Not all of them will become ion. Only part of them will become ion. That is the nature of ammonia molecule. So therefore, in the process, we say that not every one of them become ion. That will be partly ionized only. So that's why we say that it is a weak alkaline. So have a quick look of the class practice. So we have KOH, calcium hydroxide, with ammonia right there. Okay, so when we dissolve it in water, aqueous solutions of alkalines is produced. What do these aqueous solutions of alkaline have in common? In common, all of them, when we put in the solutions, they should have OH minus. Okay, all of them, they will contain hydroxide ion. And write an Ionic question to show what happened when solid KOH, solid calcium hydroxide, and also ammonia gas dissolve in water. So just now the equation is very important, is this one. Okay, always ask. Okay, when we put NH3 into water, remember this is a reversible reaction because this is a weak alkaline, so they will form NH4 plus and OH minus. So while the other one, okay, there will be KOH become K plus OH minus, calcium hydroxide. Remember, breaking up, you have like 2 hydroxide ion. As calcium hydroxide is slightly soluble, so therefore you may also want to write this arrow into a reversible equations or reversible arrow. It will be all right. Okay, so you can see that. Okay, we have reversible arrow for this as well. Okay, so I'll write Ionic equations for Ionic equation for the reaction between the potassium hydroxide and ammonium nitrate. So you have ammonium ion, the third A, with the hydroxide ion. So for this one, okay, we'll have like NH4 plus for the ammonium nitrate, hydroxide ion, okay, because we're heating, so therefore you give NH3 and H2O. And for the second one, lime water, you have to remember lime water is calcium hydroxide. And then we have HCl, okay, but because we are going to write Ionic equation, so this one should be OH minus plus H plus to give H2O. Last one, okay, we have a few drops of aqueous ammonia. Few drops, that means little amount, okay. Copper 2 sulfate. This one is a metal ion. So metal ion with alkaline, okay. Metal ion, we have like Cu2 plus. Alkaline, we have OH minus. So this one will be copper 2 hydroxide. So basically, okay, the equation is written like that. Okay, you have to be familiar to identify what type of chemical it is. For example, just now we mentioned this is metal ion, this is acid, this is alkaline, this is alkaline, this is ammonium ion. We have to recognize the type of chemicals and then we put that into the general equation that we've learned before. Okay, so to summarize these videos, first of all, you have to know that alkaline dissolve in water to give hydroxide ion. Okay, and this will be responsible for the basic properties, or sometimes we call it alkaline properties. Oh, and most of the base, okay, they are ionic compound. We do have exception, except ammonia. Number 3, okay, dissociation of alkaline. Okay, we have ions in the ionic compound become mobiles. We are talking about ionic compound become ions. Okay. And dissociation and ionization, we are talking about the ionic compound to become ions. We call that one dissociation. But if we have a covalent compound become ions, so we call this one ionization. So this one we call that ionization. And lastly, okay, that will be the ionization of ammonia, which is a weak alkaline. This equation is very, very important. So do bear in mind, okay? And in the process, it is a weak alkaline. Therefore, we have a reversible reaction, a reversible error for this as well. That's all for this video. Bye-bye.